Welcome back, everybody. This is going to be our MRS21 Fall 2020 Test Number 2 Review, Part 3. And here we have our last two questions here. Number 9 is, here it says, the table below shows the number of hours of daylight on the first day of each month in Rochester, New York. And so we have a table of the months, January, February, March, April, May, all the way to December, and different hours of daylight. Given the data, what is the average rate of change in hours of daylight per month from January 1st to April 1st? And so what we're going to do is we're going to take a look at the different hours of daylight. In this case, we'll pick red here. And so from January 1st, which of course is going to be our first month, and to April 1st, which of course is our fourth month. And so here we will take our number of hours daylight in month 4, 13.9, and we're going to subtract from that 9.4 divided by, in this case, April, which is the fourth month, minus 1, January is the first month. And so we take the difference between 13.9 and 9.4, and so that's going to be 4.5. And we divide that by 4 minus 1 is 3. Now, 4.5 divided by 3, we are going to get, in this case, 1.5. Sorry, my handwriting is not that great, ladies and gentlemen. So 1.5. All right, now this 1.5 is, in this case, average change in hours of daylight. So here, the average rate of change in hours of daylight is 1.5 hours per month. Okay, so that's what that average rate changes. But now what does this mean? It means, in this case, it's positive. It means the amount of daylight increases by 1.5 hours each month. Over those 4 months. So that's the idea, the average rate of change. If we see a positive change of 1.5 hours increasing every month, for each month, over those months from January to April. Really 3 months, because it's from January 1st to April 1st. Okay, so that's how we interpret this idea of the average rate of change. It's 1.5 hours per month. Therefore, the amount of daylight increases by 1.5 hours, which means amount increases, and in this case of daylight. So we put of daylight here. So that's what we have here for the average rate of change. Not only do we really find, in this case, the change in hours, divide by the change in months to find an average rate of change, we also need to interpret what it means in this case. Okay, so that's question number 9. Question number 10. Distance needed to stop a car after applying the brakes varies directly with the square of the car's speed. The table below shows stopping distances for various speeds. And so we see speeds for 10, 20, 30, 40, 50, 60, 70 miles an hour, and the corresponding distances that are required for stopping. So now we ask question asks for determine the average rate of change in braking distance in feet per miles per hour between one car traveling at 50 miles an hour and one car traveling at 70 miles an hour. So we see in this case that at 50 miles an hour, we're looking at this here, and 70 miles an hour for this information. So we see the average rate of change of braking distance in feet per miles per hour. So we see when the speed is 70, we have 306.25 feet required to brake, while when the speed is 50 miles per hour, the distance need to brake is 156.25. And so what we're going to do is do the average rate of change. So we're going to take, in this case, the 306.25 minus 156.25. That is going to be the feet over the miles per hour. We see this here because it gave it to us this ratio we're looking for, the average rate of change in braking distance in feet over miles per hour. So the miles per hour here will be 70 minus 50. Okay, and if we subtract 306.25 minus 156.25, we're going to get, in this case, 150 feet for every 20 miles per hour. If we simplify this, we're going to get, in this case, 7.5 feet for every miles per hour. Okay, that's our average rate of change. Now, what does this mean? Well, in this case, it means the following. It means in this case that we are going to, we will need 7.5 feet for braking distance. Okay, for braking distance for every mile per hour. Every mile per hour we travel faster. Yeah, my handwriting is terrible, ladies and gentlemen. What does it mean? Every mile per hour faster we go from 50 to 70, you will need 7.5 feet more braking distance to brake safely. Okay, so the average rate of change of 7.5 feet per mile over mile per hour represents how much more braking distance you need as you increase your speed by 1 mile per hour. So it's the average rate of change. So that's the interpretation. So we notice that every time you go a little faster, you need an extra 7.5 feet. You know, again, based upon this average rate of change between the speeds of 50 to 70. Will the average rate of change be the same? Well, we would confine this, in this case, to two different values. You know, will we get the same amount? I don't know about that. Okay. But we will see in this case that between the speeds of 50 and 70, it will be average rate change of 7.5 feet per mile per hour. And so that's how we interpret the information here. Okay, ladies and gentlemen, thanks so much for watching. This is going to be the end of our part 3 and the last part of our questions here for our review. You should be looking for something similar to some of these questions here for average rate of change in a word problem like this. Make sure to be able to show the average rate of change calculation-wise, and also being able to interpret what that means in this case. All right, thanks so much for watching, ladies and gentlemen. I hope you have found this helpful. If you found the video helpful, please make sure to give it a like. Leave any comments or questions in the comment section below. We'd love to hear from you guys, find out what you thought of the video, and of course, how we can make things better, what things you'd like to see done for future videos. All right, and of course, make sure to subscribe if you have not already, and turn on notifications to be alerted when new videos are added. Thanks so much for watching, everybody. Take care and be safe. And good luck on your test, everybody. Good luck on your test.